this problem is about reversing a linked list. A linked list is a kind of list data structure which, instead of regular lists which have an encapsulating object which stores its values such that you can index directly, a linked list is only connected through mere connections, which you can think of as values as nodes, and each node contains not only its value but also the next value or the next node in the list. And so that means that to get to any point in this linked list, you must start at the head node, which is the starting node, and keep going I number of steps to find whatever index you would like. In theory, any node can be a head node. It just depends on what was given. And a tail node is characterized by a node which demarcates the end of a list, which is by the fact that its next value would be set to none. And so that means that there are no more connecting nodes for that list. And so when we want to reverse a linked list, that basically means that we want to go from the head node all the way, hop until the tail node is reached, and then that tail node becomes our new head node for the reverse list. And so that means that as we are hopping from one node to the next, we want to ideally find a way to reverse these connections as efficiently as possible, ideally in linear time. And so if we know that we must actually go through each node, that means that we will be iterating over all of its values. And so we immediately know that we will have some sort of loop. We can do while head, and we can think about what values we would need next. If we assume that we have reached the final node in the list, so we reach the final node that we would need to swap, then we know that we need to know what the previous node was in order to make that swap. And we won't know that unless we actually store it outside of this loop. And so we want to kind of keep track of what the previous value is. And so we can just set that to none. If you think about the intuition from the start of the list, it makes sense as if we are starting from 1, its next uh, its next node or its next value should be none, because that is going to become the new end of the list. And we can see that if from 1 there's nothing, no more nodes left. And so this kind of makes sense from that point. And if you keep thinking about if you're at 2, you want to set the next value to the previous value. Now, if we think about actually the swap that we're doing, if we swap any 2 nodes, so if we're at the starting node, we swap well, the starting node, we're just having no next nodes. But if you're at the second iteration and we're swapping with we're reversing the connection from for node 2 such that 2 points to 1, and then we can go to 3, then that means that if we reverse the connection, so we set, if you're at 2 and then we set head.next equals previous, which is 1, then we can actually move forward because we don't know, we just broke the connection of our linked list because we set the next value to 1. And so what we will end up doing is actually breaking the entire list, and so we can't move forward unless we store what was the next node in that sequence before we actually make that connection swap. And so we definitely need to peek forward in the list before we actually make that connection reversal. So we can try to do this as early as possible. So want to peek forward, keeping track of what was next, because when we equate head.next, that is the point where we are reversing a connection. So that would be possibly the next step. Now that we stored the original value of what we are pointing to, we can actually make this the swap safely without breaking our reference to what was the next value. So we can define this already before actually making the swap, because now that we stored the next value, we definitely know that when we're ending this loop, that our new head will actually be the what we just peeked into. So we can already define that before we make the switch. The next logical thing would actually be to just reverse the connection. So now if we set head.next to the previous value, that would swap. So what's happening is if you're at 2, the peak would be set to 3, and then the next value for 2, we would set it to the previous value, which would be 1. And then the final step is updating the previous value to the current head, because now we have updated the previous the reverse connection, and so you would want to update the previous value for the next iteration. And this is all that's needed to actually do the connection reversal. And so once this loop ends, well, this will reach a point where head is none, and that means that we will basically, after finishing its swap like between 1 and 2, it will go to none, since that would be its next value. And so that means that the head is actually stored in the previous, which would be the last iterations. So we're basically returning the previous value. So if you run the test, this should pass, and this would be the optimal solution. That's all for this problem. Thank you for watching.